Hi and welcome to Prototype. We'll be solving the problem for LeetCode 142 linked list cycle 2. This is another problem, the LeetCode 75 study plan. Let's get to it. So given the head of a linked list, return the node where the cycle begins. If there is no cycle, return null. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, the position argument is used to denote the index of the node that tail's next pointer is connected to. It is zero indexed. The position argument is zero indexed. It is -1 if there is no cycle. Note that position is not passed as a parameter. And there is another restriction: do not modify the linked list. Okay. If you watched my LeetCode 141 linked list cycle 1 video, then you'll know that there's at least 3 ways to solve this. The first would be to modify the linked list and have a visited property, so we could traverse the whole linked list. If we reach the end, the pointer, the current node reference will become null. And in that case, we know that there's no cycle. Otherwise, we will eventually reach a node that has been modified to have the property visited, and it will show once we reach that node, then we could just return that node. We can't use that trick in this question because there's a restriction that says do not modify the linked list. Another way is to again traverse the whole node, add each reference to a set or some other memo, some other storage device, and if we see that the reference has already been added, then we can again break out of the loop and then just return the node. Let's do that one first. So we can say const memo is equal to a new set. We will need a pointer to our reference to our current node that we're at. We initialize it to the head, and then we'll have a trusty while loop, and the while condition will be that cur is not null. And also one more, because there are cycles in this linked list, or potentially anyway, that the memo, that we have not already seen the node. So memo has cur, in this case does not have cur. And each iteration of the loop will be traversing down the linked list. I would do that. We assign cur.next to cur. What are we doing at each node? We're adding it to the memo. And we can just return cur. Let's run it. Okay, it passes. We can submit. All right, accepted. Apparently it beats 97%, even as probably slightly slower implementation. So this is a linear time complexity because we will traverse every single node and then traverse one more node to get back to the start of the cycle. And we'll also be using linear space since we'll be adding a reference to the memo. Is there a better way? Of course there is. How do we do that? We can use the fast two pointers, so the fast pointer and the slow pointer method, or we can refer it to as Floyd's algorithm. And if you again watched the video for 141 linked list cycle 1, then you'll see the explanation for this. But what we'll be doing, we have a while loop. The while loop depends on the fast, because fast is the one that will become null first, because it traverses faster than the slow pointer, right? And then we will be incrementing fast by traversing down 2 nodes per iteration, and then slow traverses only 1 node per iteration. If slow is ever equal to fast, then we can break out of the loop. We know that there's a cycle. So if fast is a falsy value, so if fast is null, then we know that there is no cycle. We can return null. Okay, and let's just go through this with example 1. So we start with slow and fast at 3. Slow becomes 2, fast becomes 0. Now slow becomes 0 in the second iteration, and fast becomes 2. We do one more because slow is at 0 and fast at 2. They're not equal yet. Slow becomes -4, and then fast becomes -4. They overlap. They're the same reference, and so we break out of the loop. But notice that we're not at the start of the cycle. We're somewhere after the start of this cycle, at least in this example here. How do we travel, or how do we find the start of the cycle? Well, it turns out that there's a mathematical identity, and that is that the distance between the start of the linked list and the start of the cycle is equal to the distance between the start of the cycle and the meeting point. What does that mean? Well, what it does mean is that we can just traverse with another pointer, and we'll initialize it to head. And so while slow and slow 2 are not null, if slow is equal to slow 2, then we can return either slow or slow 2, doesn't matter. And both slow and slow 2 will traverse only one node at a time. So what's going on here? Again, in this example where slow and fast ends at -4, slow 2 starts at the head, which is 3. They both traverse only one node. -4 goes to 2, 3 goes to 2. And we've reached a point where the references will both refer to the same node. And we can simply return that node. Again, this is the result of a mathematical identity. So if you'd like to look into that, certainly it's up there in Google. Otherwise, you can just kind of remember that this is the algorithm to use. Okay, now we're missing one other thing, and that is in the instance where we have a linked list with only one node. This can fail, so we can just add a condition at the top. We can say if head.next doesn't exist, we can just return null. We can also do this another way. This, for instance, but this is more self-explanatory, I think. Okay, let's run it. Oh, looks like there's one typo here. Okay, we'll wait for it to fail. Run it one more time. There we go. Submit. There we go. Come on, one down. There we go. And turns out this time we're only 34.96%, but that's LeetCode for you. Okay, so that was 2 different ways to solve this problem. The second way we'll use constant space since we've only used 3 references, and in fact we could just stick with 2. We're done with the fast pointer once we break out of this loop, so we could just reinitialize fast to the head, but I think it makes more sense to explicitly have a third variable. Okay, so this is the solution to linked list cycle 2, LeetCode question 142. Subscribe to see more. We will be doing the rest of the LeetCode 75 study plan questions in short order. Thank you, and see you next time.